So how does a career as a researcher actually work? I'm going to talk here about academic careers because it's the ones that I know best. Careers as industrial scientist or outside of science could be quite different. But this is how a career will work if you're going to be a university academic or also a scientist at most research institutes, though not so much for commercial ones. So there's a whole series of steps. You get an undergraduate degree in physics, then you'll need to go on and get either honours or a master's, then you do a PhD. Okay, fairly straightforward. PhD is usually the gateway for getting onto a job as a researcher. What happens then is you'll typically do a series of postdocs. Now, a postdoc is a fixed-term contract temporary research job. What normally happens is that some senior researcher will get some grant funding to fund research in a particular project and will hire you to do some of that research. So for me, I did my undergraduate degree and PhD at the University of Cambridge. Then I got my first postdoc at the University of Arizona, which was an independent postdoc where I could work at anything I liked. Then I got a second postdoc at the University of Melbourne, working on a project that the person who hired me got me to work on. Once upon a time, people went straight from a PhD to a permanent job. That is extremely rare, almost unheard of, at least in physics today. You'll almost certainly have a number of these postdoc jobs. In some ways, it can be quite good because you get to travel the world, see different places. So I went from a PhD in England to a postdoc in America, then another postdoc in Australia. But increasingly, people spend more and more time on these postdocs. People can have a whole string of these jobs, still hunting for that elusive permanent job. Then finally, if you do well enough during the postdoc phases, you'll get a fixed term position typically. This would be called tenure track in the US, or it's a non-continuing in Australia. This would be more like a permanent job, but again it's typically on say a 5-year contract. So I got that at ANU in 1997 on a 5-year contract to do some teaching and some research. And then if you're very lucky, you might achieve the Holy Grail, which is in the US would be called a tenured appointment or a continuing appointment in Australia, which is a job that doesn't have an end date. That doesn't mean you can't be sacked. There are regular budget crises at universities and people get laid off. But in principle, once you get here, you can look forward to continuing in this role for a long time. Now, as you go from left to right here, your independence as a researcher has to increase. Like an undergraduate degree, you normally do what you're told. Here's an assignment, here's a project. As you get towards a PhD, hopefully your PhD supervisor will give you a good project, but you're expected to customize and work out a lot of the details by themselves, especially towards the last years of your PhD. In a postdoc, you may be working on a project that someone else has told you to do, but you'll be expected to have a lot of autonomy in how you do that. And then when you get to the last two steps, a fixed term position or continuing appointment, you're expected to be able to pick your own research projects. No one's going to tell you, research this. You've got to decide for yourself what is a good thing to research, one that's going to be productive and useful. And in the later stages, you have to raise your own money, hire other people, and you're actually steering the whole research project. So there's a big change as you go from left to right. Another change is how much time you get for research. So basically, peak research would be PhD and the postdocs. Here you're probably spending effectively 90% of your time doing actual scientific research. As you get more senior, that goes away. Fixed term positions can still be very heavily research, but normally any long-term job might be, for example, at a university, in which case you'll be expected to teach. The standard in Australia is that for academics they spend 40% of their time teaching, 40% research, 20% on administration and leadership, though ratios differ. For me it's like 90% teaching. And by the time you're a senior academic, you'll be spending again a lot of time teaching, but also a lot of time on fundraising and applying for grants and academic leadership. So very often what you do is raise the money so that you can afford to pay postdocs and PhD students to actually do the research. So it's like many jobs. You get really good at one job and then you get started to do something else. You're a really good researcher, so you end up in a senior position where you spend your entire time teaching or raising money. So permanent jobs can either be a teaching job, combined with research, or there can be technical support or administration. For example, in astronomy, many jobs would be working at an observatory or for NASA, where you might have to do the research for some of your time, but also work out, support telescope users, fix problems with the telescope, design new telescope instrumentation, handle proposals, or you could be a research leader where it's all fundraising. So there are very few jobs that allow you to be 100% research all the way through. So the biggest problem with the system at the moment is job insecurity in the middle stages, these postdoc stages and the fixed term positions. Increasingly there are huge numbers of researchers on 2-year, 3-year, 4-year, 5-year contracts. Here's the breakdown from in Australia. So this is the percentage of scientists who are on fixed term contracts. So their job has a definite end date. They might be on a 3-year contract or a 5-year contract, and at the end of that time they don't know where they're going to be working. The worst is for people at medical research institutes, where 64% of all the researchers are on fixed-term contracts. At universities it's about 45%. If you go more to the private things like private sector or defence, then people tend to be on more permanent full-time contracts. So if you want a job where you know where you're going to be in the future, definitely worth looking for the private sector, government or defence jobs, and forget about universities and medical research institutes. Now, why is this a problem? I mean, there are many careers where people change jobs all the time. The trouble is that as a scientist, it's a very illiquid job market. You have become an incredible specialist, typically at one very narrow area. Like I am the world authority on advanced statistical techniques to process quasar spectra. And how many jobs are there going to be in that? Not very many, maybe 5 in the world in a year. What are the jobs that odds that one of these jobs will be in your own city? It's very hard. A big issue is the two-body problem, as we call it, which is where often a scientist is married to another scientist and they both have to find a new job when their contracts run out, but their contracts might run out at different times, and they both have very special things which can only be done in a few places in the world, so you end up with lots of married couples of scientists who have to live in different parts of the world, or one of them has to surrender their job. So it can be very hard, just from random situations. You have to apply for a job over and over again when there are very few jobs and often lots of people applying for them. So a lot of people, and it's very hard if you're not knowing where your money's going to come from year to year, to settle down, to put kids in school, get married, have a mortgage when you don't know where you're going to be in a year. It's quite exciting when you're in your teens. It's a good life moving around, but it gets quite wearing as you want to settle down later on in life. So this is the number one thing that scientists complain about when asked about the career market. Now, how have we ended up in this situation where so many scientists are on short-term, insecure job contracts? I think a lot of this is historical accident. Here is a graph showing the number of physics PhDs in the US from 1900 all the way to 2019. And the culture of physics was kind of built in the period up to 1970, particularly between 1950 and 1970. And up till then, you look at the line here, it looks very much like exponential growth. And in fact, you can fit it very nicely with an exponential curve. So you've got a situation for, actually it goes back further than this, so over 100 years, when physics and in fact most sciences were in exponential growth. What would happen is that every professor would constantly have PhD students working with them. They might graduate 10 or 15 PhD students during their career, and most of those PhD students would go on to be professors themselves and set up their own research groups and teach another 10 or 15 PhD students themselves. But that only worked when it's an exponential growth. As you can see, since about 1970, it's changed from exponential growth to not much growth at all. If you're in a steady state, professors still graduate large numbers of PhD students, but the vast majority of those PhD students cannot replace them. And this exponential growth was always unsustainable. At this rate, everyone in the world would have a physics PhD by about the year 2150. So it was never going to work. But I don't think the culture has adjusted to flat. Still, for me as a senior academic, I am judged on how many PhD students I graduate. If you're not graduating large numbers of PhD students, you won't get promoted. But where are all those PhD students going to get jobs? They can't, if I supervise 10 PhD students, all 10 can't get a job to replace me. When I retire, maybe one person will replace me if I'm lucky. So Increasingly, this means that most scientists are going to have to leave academia and work elsewhere. And I think that's a good thing, generally. But I don't think the culture has really adjusted to make an expectation. We don't train our PhD students and master students enough about the skills they've got that are transferable to real world outside of academia jobs. And so many people still think my vision is to be a university academic, and that's not necessarily very realistic or necessarily very productive use of your skills.